Okay, so hello everyone. Our team, we have Elizabeth, Ben, Anru. We have also Diego and Vaibhav that are online, and myself, Ivana. And we've been working towards designing a low-cost ostomy bag. So a bit of context, there are 15 million people worldwide living with ostomy bags. It's this surgery that is performed when there's a colon cancer, Crohn, colitis, that consists on cutting the intestine, diverting it through the abdominal wall, and then all the stools go out from this little bit of intestine, and people need to use a bag to collect all of those stools. So the bags look like this. This design actually doesn't work very well, and it's actually very costly, especially in specific countries such as in India, where it costs $3 per bag. People sometimes need to use one per day or one every 2 days. So basically they cannot afford it a lot of times. So we interviewed a few people from India, and we want to you to hear it from them.
In India, I would say the cost problem. Like in India, we say the basic need is food, clothing, shelter. But now it is also a basic need for them, a stoma bag. So anyhow, they have to buy it. And some people, because they cannot afford, they normally keep ostomy bag for almost 10 days, 12 days. And because of that, their skin get degraded, or they start having skin problem.
The cost is too high. Surgery is just a part, but post, because it is a lifetime maintenance for you. Once you have this bag, it's lifetime. I know a person who just wraps some, cloth around their bag and they wash it because they can't afford a bag.
So as you can hear, a lot of people are creating their own like custom-made ostomy bags, and this leads to a lot of infections. So here's where we thought, okay, if we want to design this low-cost ostomy bag, what is the one thing we need to get right? So Vaibhav conducted a survey that 58 people answered in India, and we realized that the main problem was leakage and skin irritation, which is a consequence of leakage. So we decided to focus really on solving leaks. Those are some of the reasons people say they have leaks. And here's where we said, okay, our hypothesis is that leaks are happening because there's a mismatch between really the body and the adhesive that is going on there. And it creates these little blisters that then connect and create a delamination. Or maybe there's just one big blister that goes bigger and bigger. So this is where we started.
So first we wanted to sort of just establish a holistic understanding of what it means to be an ostomy bag user. And so a couple people on our team sort of did a series of 3 experiments where we wore the bag for a day. We sort of did some everyday movements with the bag, and then also added liquid to the bag to sort of mimic sort of urine deposits. So first, like a day in the life. So a couple of us wore the bag for 24 hours and then recorded our experiences. And so main takeaways of this was that the bag really has varying degrees of security depending on the movement that you do. And then also leakage is a huge problem in general. And so also near the end of the day, you'll experience sort of discomfort in terms of taking off the bag and also just in general skin irritation. And so there's some pictures of me. I think also Manu participated as well. And so another thing that we did was looking at movements, right? So an important thing for the stability is that the bag can withstand these everyday movements. So here are some videos of me and Ivana sort of doing abdominal exercises, just to see if we can test the bag and look at its durability through these methods. And so some takeaways from this is that really the importance of personalization, right? It really depends on where you apply the bag and also person to person, right? Me and Ivana have sort of different bodies, and so the ostomy bag performed at different degrees depending on who you are and where you put the bag. And so the third sort of experiment that we did was actually adding liquid into the bag. And so essentially we added color liquid using just like water with food coloring around like 50 to 100 mils in the bag, and then looked at how that would change the dynamics of the bag using this like added weight and also moisture component. And so there's a video of Ivana sort of having our like liquid and then doing again a series of like everyday movements onto some liquid. Yeah, and so just overall conclusions is that obviously the center of weight shifts, so that makes the bag a lot more precarious. And then that affects the physical movement, and then just the additional parameter of the movement of the liquid also destabilizes the bag. So just some other pictures.
Yeah, so then to understand how the delamination process works or how these bags start to fill, we sort of set up an experiment, which is in the back if anyone wants to see it after class. And so basically we used an ostomy bag. We had a simple motor that was sort of going to mimic the different motions that one does throughout the day, such as like bending, stretching, twisting. And then we had a recording system so that we could sort of monitor how the bag was progressing as time went on. And then we used PDMS surfaces to sort of mimic the stomach surface, and then we had different levers that we were using to simulate the different motions. And so we did a couple of experiments, and some of them we increased the repetitions, and then others we increased sort of the amplitude of how much is being pushed. And as you can see, we got varying results. With increasing amplitude, we were able to see a complete failure of the bag. And so we had to process the images, and to do that, Diego from our online portion of the team helped us using ImageJ, and he was sort of able to sort of manually capture the areas on where you can see the bubbles increased, sort of indicating that delamination had occurred. And this is the other experiment where we see complete failure, and as you can see, in that case, the liquid would have fully gone through the bag and leaked out.
So I'll just say something briefly about the theory and the scaling underlying this. So essentially the delamination we think is caused by a geometric mismatch and also an elastic mismatch between the substrate, i.e. your stomach, and the bag itself. That the human body has curvature to it. The stomach has what we would call Gaussian curvature, where it's curved along multiple axes. And in general, this causes issues with adhering an initially flat state, which has zero Gaussian curvature. And there is some degree of strain that is induced by that you are sort of forcing the bag to either delaminate or to stretch. So we have some examples. There's a pretty rich existing literature surrounding delamination of a sheet on a sphere, right? Something that has curvature. And you can see some examples with, a standard Band-Aid on someone's knee as they're flexing their knee. And you can see these kind of familiar blistering patterns forming. That one on the bottom is a sheet on the surface of a glass sphere. And you can see, again, these blisters coming in from the outside. I will say very briefly regarding the scaling that essentially you can consider a competition in the energy between the adhesion energy and then also the elastic energy of the bag, that you can talk about the strain of the bag based on the curvature of the sphere and then the radius of the bag itself. And so we can write the total energy density as this competition between adhesion and then these bag elastic properties, the scale of the bag versus the sphere, and then also the stretching modulus of the bag, which is this capital Y. And if you do a quick rescaling into non-dimensional units where you have this competition between the sheet size and the sphere size, and then the adhesion versus the stretching, what you see is that the naive prediction is that you're going to get a rough balance between these two things, where you expect delamination to start setting in at about this beta to the 1/4. However, this is sort of naive because it's not including the fact that the sheet is going to stretch differently in different areas. So you can do some more math and you can get a different prediction, which is covered up by the Zoom. So I will say very briefly, this inspires us to instead consider an annulus rather than a sheet on a sphere. And we'll do some future experiments on that.
Yeah, so just to sort of conclude, right, where do we move from here? So we sort of are planning on thinking about different geometries. So, right, as Ben said and talked about the theory, we want to sort of look at how do we, fix this problem. Potentially, we add sort of additional materials and adhesive materials at different spots. We can play around with the shape of the bandage, right? It doesn't have to be a circle. And so also just testing this with additional movements to see where the failure points are. And then also standardizing our image analysis, potentially working towards a more unified way of analyzing it with Python or other softwares. And yeah, so in general, we just want to thank everyone, including Vaibhav and Diego from the online team, and just in general, the Frugal Science teaching team.
One burning question. Yes.
I don't maybe I missed, but you mentioned that you tested like how much water. Did you have like a metric of like what level would you think was like willfully up impact? Is it like 0% at all, or was normal up impact?
Yes, so she's asking what it's like the ideal reduction of leakage for people. So you need to imagine that these people, a lot are actually isolated at home. They don't even want to go out because they're having so many leaks. So even having a small reduction would already be a huge difference for them. But of course, we're aiming at having like maybe, yeah, more than 50% reduction would be already huge.
Because remember, a leak once is then depending on the volume that comes out of the body. Leak is a failure. So even if there's a small pore, that is just gonna, it depends on the amount of liquid that's in the bag will determine. So, I think the goal should really be is that this is absolutely, it's like the same way as if you have a gas stove, there should be absolutely no leak. That's kind of that's the target that we should do.